Welcome to part 3 of the lesson on integration finding areas. In this example here, we're going to look at this question that's asking us to find the area of the finite region bound by the curve with equation y equals x, x minus 2, x minus 3, and the x-axis. Now, this one here is a cubic graph, cubic function. The three roots of that cubic are going to be 0, 2, and 3. So I've sketched the curve like so, and the region bound by the curve and the x-axis is this part here, but also this part here. And what we're going to look at is how we approach a problem where you have a total area formed of two different areas here. Now, if you think about the previous example, when we integrate between if we were to integrate between 2 and 3, the result we get here is going to come out negative because it goes below the x-axis. So what we actually have to do here is we have to integrate separately between 0 and 2, and then between 2 and 3 to find the total area. So let's work through that. I'm going to call this the region A, and I'm going to call this the region B. And the first thing I'm going to do to find the area of the region A is I'm going to integrate between 2 and 0 this equation here, but of course I need to expand that out first. So that would be x cubed minus 5x squared plus 6x, integrating that with respect to x. Show the result of the integration in square brackets, so 1/4 x to the 4 minus 5 over 3 x cubed plus 3x squared between 2 and 0. So evaluate for 2, 1/4 2 to the power 4 minus 5/3 2 cubed plus 3 lots of 2 squared, and I can see that when I substitute 0 into each part of this expression here, I'm going to get 0, so I'm just going to take away 0 there, because all I need to do is work out this one. So what I've got there, I've got 4 minus 40 over 3 plus 12, which comes out as 8 over 3. So the area of just part A, section A, this bit here between 0 and 2, is 8 over 3. And I'm now going to find the area of part B, and just have a think about what kind of answer you're expecting for this stage of the process. So B, I'm going to be integrating the same expression, but this time I'm integrating between 3 and 2. So I already know it's the same result, so it's 1/4 x to the power 4 minus 5 over 3 x cubed plus 3 lots of x squared between 3 and 2. Evaluate for 3, so 1/4 3 to the power 4 minus 5 over 3 times by 3 cubed plus 3 lots of 3 squared, and I know that when I substitute in 2 I get 8 over 3 because I've done it down here. So rather than show the whole evaluation over again for 2, I can just put in, take away 8 over 3, which is the result of substituting in 2. So here I'm going to get 81 over 4 minus 45 plus 27, which is 9 over 4, not forgetting to subtract 8 over 3. So 9 over 4 take away 8 over 3, I'm going to get negative 5 over 12. Now hopefully that's what you were expecting. It's come out as negative 5 over 12 because this part of the curve here has dipped below the x-axis. So what I'm going to say is that the actual area of that section is 5 over 12. And then therefore the total area A plus B. I'm going to do 8 over 3, which is the area of this bit, plus 5 over 12, which is the area of B, which gives me my final answer of 37 over 12. Now, why can't I just integrate between 0 and 3? Because if I do that, what will happen is it'll find this bit and it'll take away this bit. So rather than do what I've done, which is 8 over 3 plus 5 over 12, it'll do 8 over 3 subtract 5 over 12 and get you the wrong answer. So the message from this with integration questions finding areas, if there is no sketch provided, you must draw a sketch so you can see what it is that you're trying to work with. And if you have a curve where part of the area you're trying to find is above the x-axis and part of it is below the x-axis, you must deal with those two separately. The one that's below the x-axis, the answer will come out negative, change it to positive, add them together, job done.